Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Formation of Image by a Lens under Refraction through a Lens main chapter. So here we are going to solve each and every theory question which is there in your new edition textbook, and before watching this video my suggestion is watch the concept video. If you don't watch the concept video, this chapter mainly this video will be really confusing for you, because without drawing the ray diagram you cannot understand any question. So the ray diagram video is very much important. That is nothing but formation of image concept video. That is, where is the video, that is always available in the description box. All the videos of all the chapters are available in the description box. You just have to scroll it down. So without wasting any time, we'll start with our theory solution. Before solving the questions, we need to understand some basics. That is what we are going to learn here about the lenses. See, there are two types of lenses, convex and concave. See, based on bifocal lens and concavo-convex lens, which we have learnt in part A, using those two, there are no ray diagrams. So don't worry about those kind of lenses. We have only convex and concave when it comes to ray diagram. Simple basic questions can be asked based on those lenses which we have learnt in part A. But when it comes to ray diagram, only these two lenses. See, first thing, few things we need to understand. In convex lens, real and inverted image can be obtained. Inverted, okay, but in concave it is never possible. Okay, concave lens, real and inverted images cannot be obtained. In convex lens, virtual and erect image is possible. In one of the cases we have learnt in the concept video, correct? In one of the cases, when you keep the object between f1 and optic center, aramse we can get virtual and erect image. So here also concave lens also always, it is always virtual and erect. See, when it comes to convex lens, it is not always real and inverted. Okay, 90% of the time we'll get real and inverted. Only 10% of the chance. Okay, but that 10% is very much important, because based on the application also you can expect the question, which this is all application characteristics, all those things we have learnt in the concept video. That is why I always suggest you to watch the concept video first, then come back to this video. Okay, so in convex lens, both real and inverted as well as virtual and erect, both types of images can be obtained. But when it comes to concave lens, real and inverted is not possible. It is always going to give us virtual and erect. But when it comes to, so assume in a question they have mentioned the image is virtual and erect. Image is virtual and erect. We need to find the type of lens. How can we identify? Because in both the lenses, okay, we can get virtual and erect. How to identify? Very simple method. In convex lens, if it is virtual and erect, it will be magnified image. What do you mean by magnified? The size of the image, okay, the size of the image will be more than the size of the object. Object size is smaller than the image size. If it is convex lens and if it is virtual and erect, definitely it will be magnified. Here it is always diminished. It is always diminished. So in all the cases, okay, virtual and erect images, we are going to get only virtual images only, but always it is diminished. Diminished means the size of the image is always smaller than the size of the object. Size of the object will be larger compared to size of the image in concave lens. Okay, then I think if you know all these things, this is enough to solve all the questions. Our first question, a lens forms an inverted image of an object. Name the kind of lens. Okay, so here first question A, It is inverted image. Just from the basics, okay, in the before this question we have learned some basics about convex lens and concave lens, right? Based on that, if it is inverted image, it cannot be it is not possible in concave lens. That is very much important. So if it is inverted image, it is obviously convex lens. Okay, so if it is inverted, it is real, correct? If it is real, there is no chance we can get it from concave. In concave lens, always it is virtual and erect. See, inverted means upside down, erect means like this. Okay, if you show the object like this, image will also be like this. But when it comes to real image, if you show the object like this, image will be upside down. That is nothing but inverted. Inverted is only possible in convex, not in concave. Keep this in mind. Okay, next we'll go for the second sub question. State the nature of the image, whether real or virtual. If it is inverted, obviously it is real. That's it. Our next question, name the lens which always forms erect and virtual image. State whether the image in part A is magnified or diminished. Whatever the basics we have learnt before the first question, if you have understood that, then these kind of questions are very simple. See, question 2 here, name the lens which is always forms an erect and virtual image. See, in convex lens, virtual and erect, real and inverted, both kind of images are possible. But when it comes to concave lens, it is always virtual and erect. So what is the answer? If it is always virtual and erect, so when it comes to virtual and erect, other data will be given. Like, see here it is mentioned always. When it comes to concave, it is always producing virtual and erect. So answer is concave. If there was no data called always, then there will be a confusion, because both the lenses will form virtual and erect, but concave lens always forms virtual and erect. State whether the image part A is magnified or diminished. We know, okay, in concave lens, okay, if it is concave lens, the image is always diminished. The image is always diminished. What do you mean by diminished? The size of the image, okay, is smaller than the size of the object. Object size is bigger compared to the size of the image. Our next question, can a concave lens form an image of size 2 times the of an object? Give reason. So here, just now, previous question we learnt, okay, concave lens always produces diminished image. What do you mean by diminished? Diminished means size of the image is smaller compared to size of the object. In this question they are asking, can a concave lens, and the same lens, concave lens, forms an image 2 times the size of the object. What do you mean by 2 times the size of the object? That means whatever the size of the object is there, assume 5 centimeter, the image should be 10 centimeter, double. It is not possible, correct? In concave lens it is always diminished. So if the size of the object is 5 centimeter, size of the image is always less than that. Okay, so it is not possible. So no. Why? They are asking for reason also, because all the time, okay, whenever it comes to concave lens, it diverges the refracted rays. So if the rays are getting diverge, okay, going away from each other, they are never going to meet. They will always produce as diminished images. So how they are going to form the virtual image, all those things we have learnt in the concept video, correct? So in this case, concave lens cannot produce image, okay, size more than the object. See, not equal to the object is also possible. Size of the object is not equal to image, that is also not possible. The size of the image is always less than the size of the object. Keep this in mind, that is nothing but diminished. So here they are asking 2 times. 2 times it is not possible. Why? Because it is diverging the refracted rays. That's it. Our next question, give 2 characteristics of the image formed by concave lens. Concave lens, we know concave lens always produces virtual image. If it is virtual, it will be erect. This is one characteristic. There is one more, that is nothing but it always produces diminished image. This is very much important. These are the two characteristics. Our next question, give two characteristics of the virtual image formed by a convex lens. We know in convex lens also virtual image can be formed, correct? When you keep the object between f1 and optic center, we can arams get virtual image. If it is forming virtual image by convex lens, what are the characteristics? Very simple. See, in convex lens, if it is virtual, it will be erect. Correct. If it is virtual, it is always obviously erect, and we know what is the difference between a virtual image formed by convex lens and virtual image formed by concave lens. In concave lens, if it is virtual, it is always diminished. Okay, in concave lens, all the images we are going to get is virtual. If it is virtual, obviously it is diminished in concave. But here in this question, we are talking about convex. So in convex lens, even though it is virtual and erect, it will form magnified image. Magnified means the size of the image is greater than the size of the object. Our next question, complete the following sentences. Okay, an object is placed at a distance more than 40 centimeter from convex lens. First we need to understand which lens and more than 40 centimeter, and the focal length is 20 centimeter. The image formed is real, inverted, and whether it is magnified or diminished. See, these kind of questions you need to, sometimes a few students can easily analyze in their brain, but few students cannot. So few students will find it is difficult to understand the question only. See, very simple. First understand, first see the focal length value. Whenever two values are given, first see the focal length value. Focal length value is 20 centimeter. That means if it is 20 centimeter, it is very clear that from the optic center, okay, to f1. See, always focal length means from the optic center to f1, that distance, okay, that is 20 centimeter. So whatever the distance we have here, the same distance we have here, correct? So it is again 20 centimeter. From here to here 20, from f1 to 2f1 it is 20. So from 2f1 to optic center it is 40 centimeter. Okay, this much knowledge you should have. So here it is clearly mentioned that more than 40 centimeter. More than 40 centimeter means anywhere here. Object is placed somewhere here. Now we know if it is if the object, okay, is beyond 2f1, it is always going to produce, okay, diminished image. If it is at 2f1, the size of the image will be equal to the size of the object. As the object crosses this 2f1, the size of the image will keep on increasing. All these things we have learnt in the concept video, correct? So if the object, this is how you need to analyze. If the object is beyond 2f1, it is always diminished. If it is at 2f1, the size of the image is equal to the size of the object. Once it crosses 2f1, okay, somewhere between 2f1 and f1, the size of the image will be greater than the size of the object. There is nothing but magnified. So now in the first case, okay, first question, it is clearly mentioned that more than 40 centimeter, that is nothing but more than beyond 2f1. So it is real, inverted, and diminished. See, this is how you need to understand. Okay, once you get some doubts, okay, you can just go back and rewatch it. You will definitely understand. Okay, next, an object is placed at a distance 2f from convex lens, a focal length f. The image formed is dash that of an object. See, here it is clearly mentioned the object is placed at 2f, okay, and the focal length is just f. We don't know the values, correct? So now remove all these values. Now understand the distance from optic center to here, it is f. So now this distance is f, and the complete this distance is 2f, and it is clearly mentioned that object is placed at 2f1. 2f is nothing but 2f1. Okay, both are same. If the object is placed at 2f or 2f1, the size of the image is equal to the size of the object. So answer for this question will be equal to the size of object. Next, sub question C. If an object is placed at a distance 5 centimeter from the convex lens, a focal length 10 centimeter. See, object distance is only 5 centimeter and focal length is 10 centimeter. First, always find the value of focal length. Focal length is 10 centimeter. That means from optic center to here, it is 10 centimeter. And the object is placed, okay, that is only 5 centimeter. From object to optic center, it is 5 centimeter. When we know, when the object is placed between F1 and optic center, we are going to get virtual and erected image in terms of convex lens. If it is virtual and erect, we know it is definitely going to form magnified image. So in convex lens, if it is virtual and erect, okay, it will be definitely magnified. If it is virtual and erect, in case of convex lens, it is always magnified. So all these things are based on ray diagrams only. If you understand the ray diagrams properly, then these kind of small things will definitely help you to solve these kind of questions. Our next question, state whether the following statements are true or false by writing T or F against them. Okay, a convex lens has a diverging action and concave lens has a convergent action. So convex, see, convex means it is converging. Convex means it is converging. This is what we are learning from the part A of this chapter, correct? So this is completely wrong. See, A is false. Why? Because convex is always converging in nature, concave is always diverging. Converging means all the refracted rays after refraction they are going to meet at one point. Diverging means after refraction they are going away from each other. That is the nature of concave. Next, sub-question B, a concave lens if kept at a proper distance from the object can form its real image. So we have learned that in concave lens there is no chance that we are going to get the real image. So this is also false. At what distance you place, whether you are going to change the distance from the object to lens or lens to object, that means you are moving the lens or moving the object, okay, at whatever the distance it is, real image is not possible in concave. Keep this in mind. A ray, okay, sub-question C, a ray of light incident parallel to principal axis of a lens passes undeviated after refraction. We know if it is parallel, okay, if it is parallel in both the lenses, first we'll talk about convex. If it is convex, if it is parallel to the principal axis, it will converges. When it comes to concave lens, if it is parallel to principal axis, it will diverges. But here what is telling, passes undeviated. Undeviated means if it is like going like this after refraction also it will go like this. If it is going like this after refraction also it goes like this. So this is a wrong statement. So in which point, okay, at what point it will go undeviated? Only when the rays are passing through optic center. In both the lenses, if the rays are passing through optic centers, it will go undeviatedly. But here it is not going through the optic center. It is clearly mentioned it is in parallel rays. Okay, next, a ray of light incidented at an optical center of a lens. Optical center, that is nothing but optic center, passes undeviated. Just now we have learnt in any of the lens, if it is passing through optic center without deviation, it passes straightly. That is nothing but undeviated. So D is true. Sub-question E, a concave lens forms a magnified or diminished image depending on the distance of an object from it. We know in concave virtual images are formed always. If it is virtual, it is always only when it comes to concave. In concave lens all the time it is virtual and all the time it is diminished. Keep this in mind. So option E, okay, sub-question E is also false. That's it. Our next question, where must be a point source of light be placed in front of a convex lens so as to obtain a parallel beam of light? See, that means we need to understand a few things here. point source of light. That means a source which is producing light, like a candle, that is nothing but point source of light. So here from a candle we are not going to get point source, correct? It's a very big source. Point source, like it is like a more like a laser light, okay, in front of convex lens to obtain parallel beam of light. To obtain means after refraction it has to form parallel beam of light. See, for this condition the object has to be placed at f1. Keep this in mind. The object has to be placed at, okay, should be placed at f1. That's it. If you place the object, that is nothing but point source light, at f1, will get parallel beam of light. Keep this in mind. These are the note points you should note somewhere so that it will be helpful for your exams. Our next question: what are the three principal rays that are drawn to construct a ray diagram for the image formed by a lens, but they have not mentioned which lens? Draw a diagram to support your answer. See, they have not mentioned which lens. In the exam, if they are asking these kind of questions, they will definitely mention either one of the lens. So we will learn both the cases. In both the lenses also we are going to draw all the three rays, so you will understand. If you know the ray diagram, this is a very easy question for you. First, it is parallel to principal axis, then it is passing through optic center, and it is not parallel to principal axis. And see, whenever we are drawing the ray diagram, you have to use a scale, and arrow marks are very much important. If the arrow marks are missing, you are not going to get the marks. The same three rays, parallel to principal axis, passing through optic center. You see, in here this ray is not parallel to principal axis, correct? There is no rule that you have to write like this only, okay? You can, if it is not parallel to principal axis, you can draw it like this, you can draw it like this, you can draw it like this. Anything is possible. This is also possible, okay? These are the three principal rays they are talking about. So they are not just asking this one. After refraction, what happens? See, we know in convex lens, if it is parallel to principal axis, it will converges at f2. It will converges at f2. If it is passing through optic center, it passes without deviation. If it is not parallel to principal axis, see, this is the principal axis, right? If this ray is not parallel to principal axis, after refraction it becomes parallel. So these are the rays they are talking about. If all the distances are proper and the lower part of the lens is equal to the upper part, the length, okay, this length is equal to this length, all the three rays are going to meet at some point. In this case it is not meeting because this part, okay, the upper part is bigger than the lower part. That's why there is a small error. If both are equal, obviously all these rays are going to meet at one point. That is why the convex lens is called as converging lens. When it comes to concave lens, that is nothing but diverging. If it is parallel, after refraction it moves away from the principal axis. If it is passing through optic center, it passes without deviation. See, arrow marks are important. Then if it is not parallel to principal axis, it becomes parallel after refraction. So these are the three principal rays they are talking about. And in the exam they may ask all the three rays or any one ray. Specifically, you have to be ready with both the lenses. Our next question: in the diagrams below, x dash represents the principal axis in both the cases. O is the optic center and F is the focus of the lens. Okay, F is nothing but F1 only. Then complete the path of rays A and B as they emerges out of the lens. See, first thing, if you know the previous diagram, okay, the conditions for three principal rays, also you can draw this diagram. See, in both the lenses, one ray is passing through optic center, B. In both the lenses, it is passing through optic center, and A, in both the lenses, the ray A, this ray is not parallel to principal axis, and this ray A is also not parallel to principal axis. These are the given condition. We know if it is passing through optic center in both the lenses, it passes without deviation. Correct, in both the lenses. Next, arrow marks are very much important. Next, ray A in convex lens it is, this ray is not parallel to principal axis, correct? So after refraction it becomes parallel, then when it comes to concave lens, see here, this ray A is not parallel, again it is not parallel to principal axis in both the lenses after refraction. See, refraction will occur not from the here, say here, okay, not on the from this surface, at the midpoint, okay, midpoint. So when it reaches the midpoint it starts refracting. So if it is not parallel to principal axis, after refraction it becomes parallel to principal axis. So these are the two rays they are talking about. Our next question, distinguish between a real and virtual image. Very simple. See here, real images are formed due to the actual intersection. Real images are formed due to the actual intersection of refracted rays. So I'll write it as R rays. R rays means refracted rays, assume like that, but in the exam you should not use these short forms. Okay, when it comes to virtual images, okay, the refracted rays appears to meet the refracted rays, see, virtual images formed because due to the refracted rays appears to meet. Because of this one, virtual images are formed. Then real images can be obtained on the screen. It can be obtained on the screen. See, you have to write it in full form when you are writing in the exam. Screen means they will not understand. For you, just to save the time, we are using the short forms. Understand and make a note of it. Screen, and in virtual images they cannot be obtained on screen. X means it is not X, it is opposite to this statement. Okay, this can be, real images can be obtained on the screen, virtual images cannot be obtained on the screen. Next, the last point, real images are always inverted. Virtual images are always erect. That's it. Our next question, a lens forms an upright and magnified image of an object. Name the lens, draw the label diagram. See here, need to understand the question properly. A lens forms an upright. What do you mean by upright? Upright is nothing but erect. Like this. Image will be like this. It is not upside down. It is like this. Upright means erect, and magnified. See, we know in concave lens it is always virtual and upright. Upright is nothing but erect. Virtual and erect is nothing but virtual and upright only. So here they have used upright, that's why we are going to use upright only. In concave it is always virtual and upright, but we know it is always diminished image. So whenever you get to know it is a magnified image, it is never concave lens. Keep this in mind. If it is a magnified image, it has to be convex lens. Okay, so here we got to know it is convex lens. So the answer A is convex, because these kind of questions are called +1 type questions. So +1 type, that means if the first sub question is wrong, whatever you write, okay, as a second sub question, that will be considered as wrong even though that is correct. Why? Because the diagram is completely based on your answer in part A. If this is wrong, whatever the diagram you write, we will consider it as wrong. This is how board examination works. This is how we correct papers in the board exam. Okay, it is not compulsory for all the questions. Okay, only for few questions we call it as +1 type. Okay, next, draw the labeled ray diagram. Okay, they are talking about, see, lens has to be clean. Okay, only because I am drawing it on the board, it is not proper, and the upper part should be equal to the lower part, then only the values will be proper. Next, so here they are talking about virtual and upright. Correct. Upright means virtual and erect only. If it is upright means obviously virtual image only. To get virtual image, okay, the object has to be placed between F1 and optic center, then only we'll get the virtual image. So one parallel ray, one passing through optic center. So here, so when these rays, okay, if it is parallel, it passes through f2. If it is passing through optic center, it will pass just like that. So these rays are never going to meet. This is what we have learnt in ray diagrams, correct concept video. So they are never going to meet. Definite, that means definitely we are going to get the virtual image. How to get the virtual image? Extend these two rays, okay, extend these two rays backward in a straight line. Okay, it has to be very straight. Wherever we are going to get this intersection, there we are going to get the image, and this will be, okay, between f1 and 2f1. The image will be between, okay, almost near to 2f1. So if the object is ab, see they have mentioned labeled diagram ab, then the image will be a dash b dash. If you draw the diagram like this, definitely you'll get full marks. Our next question, in each of the following cases, where must be an object be placed in front of a convex lens so that the image formed is, see it is clearly mentioned that it is convex lens. So we have A, B, C, D, okay, we'll go one by one, okay. Here, to get the image at infinity, see the A, B, C, D are the positions of the image. So they are asking, if these are the positions of the image, where should be the object be placed in front of a convex lens? See, we know, if you know the ray diagrams properly, these kind of questions are very easy. If you want to get the image at infinity, the object should be placed at f1, or you can write it as at focus. At f1 is also correct, at focus it is also correct. Then of same size of the object, see the image size should be same size of the object, so it has to be kept at 2f1, at 2f1, okay, or you can write it as second focus. Next, sub question C, inverted and enlarged. Enlarged means magnified. We know in convex lens most of the cases we are going to get a real and inverted only, and where we are going to get magnified image. See, if you keep it at 2f1, the size of the image will be equal to size of the object. If you keep it between 2f1 and f1, between 2f1 and f1, so here this and between short forms you should not use in the exam. You are going to lose marks for every question. If you do like this, more than 15 marks you are going to lose. So all these short forms you have to avoid in the exam. Next, upright and enlarged, it's clearly mentioned it is convex. If you want to get upright means erect image. If it is erect, definitely it is virtual. If you want to get virtual and erect image in convex lens, it is obviously it has to be placed between f1 and optic center. In the full form you have to write f1 and optic center, or you can write it as focus and optic center. Anything is fine. This question number 6, complete the following table. See, based on the ray diagram and whatever we have learnt, based on all those things, this table has to be completed, and take this as an assignment. Very easy concept. So where is the position of object, what type of lens, and what is the nature of the image, all those things you can aramse verify the ray diagram video and write it here. That's why, anyhow, it's a very direct question, no logic behind it. That's why we are going to skip it. Our next question, study the diagram given below. Name the lens L, L dash. We have many sub questions, will go one by one. Listen, how to identify what kind of lens based on the diagram? Very simple, whether it is converging or diverging. So we know based on the converging nature or the diverging nature, we can aramse identify what kind of lens it is. So here we know whenever the rays are after refraction, it is converging, it is nothing but convex lens. See, if you know these kind of basics, you can aramse solve many questions in the board exam. When it comes to ray diagrams, see here they have given the ray diagram, so we can aramse answer the following questions. But when it comes to drawing the ray diagram, the rays, okay, the rays has to be straight. They'll just see whether you use the scale or not. If you have not used the scale, if the lines are not straight, they will deduct marks. And for every ray, okay, for completing the every ray, not only the incident ray, refracted ray also, okay, if both are correct, 1 mark will be allotted for one single ray. How many rays we are going to use? Maximum 2 rays. Completing 2 rays, you will get 2 marks. Remaining things, whether the image is inverted or virtual, based on that you are going to get the, okay, now here it is clear, it is convex lens. Why? Because it is converging. Second one, what are the points O and O dash called? Whenever we are learning the diagram, we did not learn O dash, correct? What is the only O we know? That is optic center. See, from the optic center, what is the first point? That is always focus, correct? That is always focus. We learnt F1 to F1 and it will continue. That side F2 to F2, correct? So what is the first point when it from the optic center? That is nothing but focus, F1, correct? So here this is the first focus and this is the second focus. So O is the first focus and O dash is the second focus. That's it. Third sub question, complete the diagram to form the image of an object AB. Okay, listen, if this is the first focus, okay, they have told AB, correct? If this is the first focus and this is the optic center of the lens, whenever the object is placed between focus and optic center, what kind, we know this is convex lens, correct? We know this is convex lens, and how to draw the ray diagram, all those things we have learnt. Based on that only this concept, this complete theory solution is based on. So you have to learn all those things first, then this video will be useful. Now listen, when the object is placed between optic center and optic center, when the object is placed between focus and optic center, what happens when it comes to convex? It forms virtual image. This is the, when the object is placed between focus and optic center, what happens when it comes to convex? It forms virtual image. This is the only case where we are going to get the virtual image. So next, see, and this one also, when it passes through optic center, it passes without deviation. So whenever the object is placed between focus and optic center, that too in convex lens, okay, it is going to form virtual image. For virtual image, what we have to do, in extending back the refracted rays, these rays you have to extend back, okay, where these two are going to meet, there we are going to get the image. Okay, this will be between, okay, almost close to second four, okay, to F1, if this is F1, the image will be really close to 2F1. Okay, now the image is A dash and B dash. This is the diagram they are looking for. That's why the ray diagram video, the concept video of part B is very much important. See, every year they'll ask one numerical and one ray diagram based on the lenses. So both the sign convention and ray diagram, it is very much important. Next, okay, diagram is done. State the three characteristics of the image. So we know this is the image, correct? One, this is virtual image because it is formed on the same side of the object and it is upright, correct? If it is real, it will be inverted. Now anyhow it is erect or upright, okay, it cannot be real image. So virtual, erect and magnified. We know when it comes to convex lens, if it is virtual, it is always magnified. Our last sub question, name a device in which this action of lens is used. So while learning the ray diagram, for every case we have learnt the application also. Here also they are asking for the application where we are using it. These kind of lens where we are using it in magnifying glasses or reading glasses. Okay, magnifying glasses, or you can write it as a reading glass. Anyone you can write, you'll get full marks. Our next question, study the below diagram and answer the following questions. So first, name the lens L dash. So here we can easily say the incident ray after refraction, it is diverging, it is going away from the principal axis. That means it is concave lens. That is the only difference between the previous case and this case. So here concave lens. Next up, what are the points O and O dash called? Here you have to be very careful. We know when it comes to convex lens, convex, this is not convex, this is concave. When it comes to convex lens, left side f1, 2f1, 3f1, it keeps on going. Right side f2, 2f2, correct? So this is f1. This is f2 in terms of convex lens. But when it comes to concave lens, this is concave lens, right? This side it is f2 and that side, right side, it is f1, exactly opposite. So when it comes to O and O dash, in this case O is second focus, O is second focus, O dash is first focus. This difference you should know. Okay, O is second focus and O dash is first focus. You can also write second focal point and first focal point, anything is fine. Third one, complete the diagram, okay, to form the image of an object AB. Here you have to be very careful. Even though everything, the diagram is correct, okay, first we'll complete the diagram, then I'll teach you that. Okay, see, here we know everything is going to be diverging in nature, correct? All the rays are going to be diverged, but they are never going to meet. So what we are going to do, say these are the two rays, correct? If it is passing through optic center, okay, it without deviation it passes in both the lenses, it is never going to meet. So what we are going to do, so we have to reverse it back. Okay, if you take the scale and do, you will get the proper image, and reverse this image, this refracted ray also backward. So here they are going to meet. So there we are going to get the image. So once you form the image, everything is correct. Then also how to lose marks. These are the things you have to be very focused. See here, it is not AB, it is BA. Here you have to be very careful. This is not AB. Most of the time here you are going to get AB, A and B. Sometimes it will be M, N, whatever the letters you are going to use, you have to use it very carefully. So here instead of AB they have given BA. So this will become B dash A dash. If you write A dash and B dash, done. Okay, so whether to write B dash A dash or A dash B dash, all those things depends upon the nature of the image. If it is erect or virtual image, okay, whatever the letters we have given, you have to use it same, because it is erect, it's not upside down. If the image is upside down, AB becomes, okay, sorry, BA becomes A dash and B dash if it is upside down. Okay, now diagram is done. What is the next sub question? State three characteristics of the image. See, it is erect. If it is erect, definitely it will be virtual. Virtual. Okay. Then erect. You can write it as upright also, and diminished. See, if it is concave lens, always it is going to form a virtual image only. All the virtual images are erect, and all the virtual images only in concave lens is always diminished. If it is virtual in convex lens, it is magnified. And virtual in concave lens, it is always diminished. Our next question, see this question, the object is placed between F and optic center, focus and optic center, and that is convex lens. This diagram we have learnt in concept video only. So this is the case 6 of convex lens. Aram se, if you have seen that video, there is no need to draw it again because there is no change in the question. The exact question what we have learnt in concept video. If it is exactly same, we are not going to do it in theory solution. It is case 6 of convex lens. Our next question, this question, see here, this question, the diagram, see the diagram, the object is beyond f1, but it is there, f2 is not mentioned. If f2 is not mentioned, that means the object is between f2 and f1. Keep this in mind. Okay, if f2 is mentioned, then you have to see the position of the object. Now f2 is not mentioned, so you have to assume the object is between, f1 is mentioned, the object is beyond f1, and f2 is not mentioned. That means object is between f1 and f2 only. This is case 4 of convex lens, and this is what we have learnt in concept video, and there is no change. Our next question, here the position of object is not mentioned. Instead of that, the position of image is mentioned. The position of the image is beyond 2f2, beyond 2f2. In which case we are going to get? That is nothing but case 4 only, case 4 of convex lens. So there is no change in the question, that's why we are going to skip it. If you have any doubt, and when it comes to ray diagrams, you have to draw and practice. If you leave it like that, during the exam some or the other silly mistakes you will do and lose marks. Even though you know the concept, why you have to lose marks? So draw and practice. This is case 4 of convex lens. Our next question, here also in this question they are not talking about the object distance, where the object is placed, or where the image we are going to get. Instead of that, he has given one hint. What is that? The image height, okay, size of the image is equal to the size of the object. So what do you mean by that? That means the object is kept at 2f1. Object is kept at 2f1. This is nothing but the case 3 of convex lens. That is what we have learnt in concept video. That's why there is no change in the question. That's why we are going to skip it. Our next question, a lens form an erect, magnified and virtual image. Here, out of these three characteristics, which is very much important? If it is virtual, it is always erect, correct? If it is erect, it is always virtual, which is the middle characteristic, that is magnified. Whether the image is magnified or diminished. See, when it comes to concave lens always it is virtual and erect, but all the images are diminished. But when it comes to virtual, erect and magnified, that word magnified is very much important when it comes to virtual images, because it is only possible in convex lens. Out of convex lens, in which case is that? Case 6, the last case of convex lens. So here also there is no change in the question, direct question only. If you analyze the question properly, it is direct question only. Now this question we are going to skip because there is no change in the question. This is case 6 of convex lens. That is what we have learnt in concept video. The concept video, you know where the link will be. It is always available in the description box. Our next question, a lens always forms an image between the object and the lens. Name the lens. Draw the diagram. Listen, first we have to understand the question. A lens always forms an image between the object and the lens. If the object is here and the lens is here, the image is always formed between the object and the lens. This is the condition they are talking about. Okay, when it comes to convex lens, image will never be formed between object and the lens. Okay, it is only in concave lens. In all the cases of concave, we have 0, 1, 2. Correct. We have three cases. In that, case 0, case 1, case 2. Case 0, we are taking it as the object is at infinity. That's why we are taking it as 0. Case 0, 1, 2. In all the three cases, image is between, okay, object and the lens only. But here it is clearly mentioned that object, okay, object, we have to see the object. So which is that? That is nothing but you only in case 2 of concave lens we can see object as well as image. That's why, so this is case 2 of concave lens. That is what we have learnt in concept video. Our next question, classify as real or virtual the image of a candle flame formed on a screen by a convex lens. See here and draw the ray diagram. Here again we are not going to draw the ray diagram. I am going to give you the hint and cases. You can aram se watch the, if you know the cases, aram se you can draw it, or else you can aram se go back to the concept video and watch it. Listen, Classify as real or virtual the image of a candle flame formed on the screen. Whatever the image is formed on the screen, the word screen is very much important. If the word screen is mentioned in the question, that means it is always real image. Real images can be obtained on the screen. Virtual images cannot be obtained on the screen. So here the question is, classify as real or virtual the image of a candle flame formed on a screen. So if it is forming on a screen, it is always real image, okay, and it is clearly mentioned it is convex lens, but the size of the flame or size of the image is not mentioned in the question. So any question, any cases, okay, any cases where you can see both object as well as the image, and the image should be real and inverted, any case you can select, okay. From case when it comes to beyond 2f1, at 2f1, between 2f1 and f1, okay, all these cases are going to give you the same results only. So here the important thing is size of the image, that is not mentioned in the question, so you can go for any one of these cases. Our next question, show by a ray diagram that a diverging lens cannot form a real image of an object placed anywhere on its principal axis. See, diverging lens is nothing but concave lens. So just we have to draw the diagram. How many cases we have? 3 cases, case 0, case 1 and case 2. But here is clearly mentioned, wherever you keep the object on the principal axis, it is always going to form an virtual image, correct? So we have to show the object also. That is why this is case 2 of concave lens. Case 2 of concave lens. Our next question, draw a ray diagram to show how a converging lens can form a real and enlarged image of an object. These are cases of the convex lens and concave lens, correct? That's why we are going to skip it, because we have learned thoroughly in the concept video. I'm just going to give you the hint which case where is the object is placed. See, the image is going to be real and enlarged. The important thing is enlarged. Enlarged is nothing but magnified. See, he has not mentioned magnified or highly magnified. Highly magnified is very much important. Here it is just mentioned enlarged. Enlarged means magnified. See, when the object is placed between 2f1 and f1, when the object is placed between 2f1 and f1, we are going to get the magnified image. So that is nothing but case 4 of convex lens. Our next question, a lens form an upright and diminished image of an object placed at its focal point. Name the lens, draw the ray diagram to show the formation of image. See, here the important word, which is the important word? Upright, right? No. In both the lenses we are going to get upright image, correct? In upright is nothing but erect, okay. If it is erect, it is virtual. In both the lenses we are going to get virtual image, correct? But when it comes to diminished image or magnified image, based on that we are going to identify the lens. If it is virtual, in convex lens, if it is virtual, it is always magnified. In concave lens, if all the images are virtual only and all the images are diminished only. So here it is clearly mentioned upright. Upright means erect. If it is erect, then it is virtual image. If it is virtual and diminished image, we have clearly mentioned diminished image, so it is concave lens. So we have name the lens concave lens. Draw the diagram case 2 of concave lens, because in case 0 and case 1 we cannot see the object. Only in case 2, okay, object it will be in a feasible distance, okay, minimum distance, so that's why we can see the object. So this is case 2 of concave lens. Our next question, draw a ray diagram to show how a converging lens is used as a magnifying glass. This word magnifying glass is important. To observe a small object, mark on your diagram the foci of the lens and the position of the eye. Here this is very simple question. The only thing is position of the eye, that is very much important, that we have not learnt in concept video. That's why this question I am going to draw it on the board. Okay, listen, magnifying glass, reading glass, that is nothing but case 6, the last case of the convex lens. So not only learning the ray diagram, to understand the application is also important. If it is magnifying glass or reading glass, any one word is mentioned, that means it is convex lens only, and the object is between f and optic center, between optic center and the focus. So this is the last case 6 of the convex lens. So lens will be here, this is focus, okay, this is optic center, and the object is between, anywhere you can place it anywhere. So I'm going to draw the rough diagram just to make sure we are finishing it faster. So if it is okay parallel to principal axis, okay, it has to pass through F2, okay, and if it is passing through optic center, there will be no deviation. Anyhow, these two rays are not going to meet, that's why we are not going to get the real image. Extend these two, okay, extend these two, where these two are going to meet, okay, that will be between, okay, 2f1 and f1, okay, here somewhere here we are going to get the image. This will be virtual, okay, this is virtual image. And if you take A, B, this will be A dash, B dash. Now all the foci means the plural form, f1, 2f1, f2, all those things are mentioned. The only missing thing is the position of eye. The position of eye will be somewhere here. That's it. So if you see in this angle, you're going to see the virtual image. Our next question, draw a ray diagram to show how a converging lens forms an image of the sun, hence give a reason for the term burning glass for a converging lens used in this manner. See here the important words are two, sun and burning glass. So burning glass is an application and sun is the object here. Where is the sun? At infinite distance. So the object is at infinite distance. This is how you have to analyze the question. So object is sun, image of the sun means we are going to form an image of a sun, but where sun is at infinite distance. So object, the sun is the object, sun is at infinite distance. So this is case 0 of convex lens, case 0 of convex lens. If you know case 0 of convex lens, all the rays will be parallel to the lens, all the rays will be parallel to the lens like this. See, convex lens, all the rays, okay, will be parallel to the lens. If it is parallel, what happens? If it will definitely passes through f2. Okay, all the rays are parallel and all the rays are intersecting at f2, all the rays are focusing at f2, that means intersecting. So every ray has some power, all the rays are meeting at one point, that means power is more, the power of sun rays are more, intersecting, okay, focusing at one point. That's why it is considered as burning glass. That's it. Our next question, state the changes in the position, size and nature of the image when the object brought from infinity up to the convex lens. Illustrate your answer by drawing the ray diagrams. So this is nothing but, this question is nothing but, okay, all the cases of convex lens. You have to draw the ray diagrams of all the cases from the infinity, case 0 to case 6. So from 0, object is at infinity. Case 1, okay, it is too far. Case 2, beyond 2f1, the object is coming near to the lens. Okay, all these cases you have to draw the ray diagram. Keep one thing in mind, okay, when the object is at, okay, infinity, the size of the image is pointer. As it comes towards the lens, okay, near to the lens, the image will get bigger. This point you should know, okay, if you know this point, aram, so you can draw the ray diagrams. So just draw it yourself, try, because the ray diagrams are very much important. Every year they are going to ask it for 3 or 4 marks. Our last question, state the changes of the position, size and nature of the image when the object brought from infinity up to a concave lens. Illustrate your answer by drawing the ray diagram. See, previous question was about convex lens. This question is about concave lens. That means all the 3 cases, case 0, case 1, case 2, is asking us to draw the diagram. That's it. So now we have, see, most of the questions we have skipped, not drawn on the board, because those are the same diagram which we have learnt in the concept video. That's why we have skipped it. If any difference is there in the question, we have learnt it, correct? Like this sun and magnifying glass, and the focusing eye, where is the eye, position of eye, all those things. If those kind of questions, we have drawn it on the board. So always learn the concept video properly. Now we have completed all the theory questions from the lens part B. Next is sign convention, very important. Every year, based on the sign convention, numericals will be there in the board exam, and all the questions in the board exam will be very easy. Just you have to identify which is u and which is v, which is object distance, which is image distance, and what is the sign convention, whether we have to put plus or minus. All those things we are going to learn in sign convention concept video. That is very much important, because in the concept video we are going to learn where we are going to use plus and minus, all those things. After that, numericals. So all those videos will be available in the description box. Watch it and learn everything. Thank you.